Bayaw. I'm here to give an example in fluid mechanics from Chapter 8, the open channel. A 4-meter wide rectangular channel is designed to carry a flow of 20 cubic meter per second. Calculate A, the critical depth, and B, the critical velocity. So the given in this problem are B, which is the wide, is equal to 4 meter. Q, which is the total flow, is equal to 20 cubic meter per second. So find the critical depth and the critical velocity. So first, we need to find the unit flow. So the formula to unit flow is Q is equal to Q, which is big over P, is equal to 20 cubic meter per second over 4 meter. Simplify, so our unit flow is equal to 5 cubic meter per second. So first, to find the critical depth, the formula is critical depth is equal to cube root of Q squared over G. Substitute, so DC is equal to cube root of 5 cubic meter per second raised to 2 over 9.81 meter per squared second, which is the constant gravity. So simplify, then the result was 1.366 meter. So this is our critical depth. So next, to find the critical velocity, the formula is Q is equal to VC times DC. Substitute, 5 cubic meter per second is equal to VC times 1.366 meter. Simplify, so our critical velocity is equal to 3.66 meter per second.